proportional relationships less than 6 notes. Okay, we're back to where we left off of the notes, back to talking about the traveling car problem. And underneath where it says slope, we're going to find the slope of the traveling car problem above. We're going to find the slope of the traveling car problem. So we are going to use these 2 points that we mentioned. x1, y1 will be the 2, 100. x2, y2 will be the 5, 250. Okay, so it's the points we used earlier. We're going to use those points to find the slope of the traveling car problem. So again, we're going to use 2, 100 and 5, 250. So let's call this x1, y1, and we'll call this one x2, y2. Again, it really doesn't matter which one you call the 1s and which ones you call the 2s. I just always call the first point the 1s and the second point the 2s. So let's find the slope. So slope equals y2 is 250 minus, I might need to make my line a little, y1, which is 100, over x2, which is 5, minus x1, which is 2. So again, the slope for the traveling car problem, I would take 250 minus 100 over 5 minus 2. I know we could just put it directly into our calculator, but I'm going to simplify the top. 250 minus 100 would be 150, and 5 minus 2 is 3. 150 divided by 3 is 50. So once again, just like we've got above, we got the answer of 50 because the slope is a rise of 50 miles per 1 hour. So 50 miles per hour. So my slope is 50 over 1. Let's actually change this right here to 50 over 1. My rise is 50, my run is 1. 50 miles over 1 hour. All right. Now let's find the unit rate of the traveling car problem. Let's find the unit rate. So we're going to pick any point on the graph. Let's pick a different point. Let's pick one that we haven't used yet. So let's pick one that we haven't used. Let's use, how about this point right here? That point right there would be 150 miles and 3 hours. So my rate, I'm going to put miles over hours because we want to find the miles per hour. So we're going to put miles over hours. All right, so my rate again. For the rate, I'm going to put 150 miles over 3 hours. Where did we see that before? Right up here. Remember, to go from a rate to a unit rate, we divide. To go from rate to unit rate, we divide. Go ahead and write unit rate like this. But from this point forward, I'm never going to write out unit rate. We're going to put UR for unit rate instead. We'll use the letters UR to represent the unit rate. So my rate was 150 miles in 3 hours. The unit rate would be to simply take 150 and divide it by 3. And that would be 50 miles per hour. So my unit rate is 50 miles per hour. So let's just take a moment now. So for this traveling car problem, let's start with the rate of change. What was the rate of change? The rate of change was 50 miles per hour. What was the slope? The slope was 50 miles per hour, because 50 miles over 1 hour. Go up 50 over 1 hour. And then the unit rate, again, was 50 miles per hour. So from all of this, what do we know? Well, we know that the rate of change, the unit rate, and the slope of proportional relationships are all the same. So if you have a problem that has a proportional relationship, in other words, if you have a problem that is a linear equation, if you have a graph that is a line, then its rate of change, its slope, and its unit rate are all the same thing. This is very, very important that you get this. Okay, so rate of change, unit rate, and slope are the same. Rate of change, unit rate, and slope are the same. Again, unit rate, rate of change, and slope, they are all the same when it comes to proportional relationships. It's going to be very useful because in the problems we're about to do, you could do them different ways. You could find the slope, you could find the rate of change, you could find the unit rate, and so forth. All right? Because they are all the same thing when it comes to proportional relationships. All right? If you have any questions on that, please let me know.